management system, or maybe even SharePoint as a content management system. I think my tongue is going to fall off and catch on fire for saying SharePoint. But yeah, so yeah, I'm here to talk about container management systems. I'm excited about it. Who else is excited? You're excited. So excited. Oh, yeah. Woo! Are you good?
I am very good. I'm streaming. We're streaming.
Perfect.
You're live.
So about me, I work as of about a month ago with this high-speed individual named Warren at IronNet Cybersecurity. It's a super awesome company. We do like behavioral analytics against network traffic, and it's amazing. It's awesome. It's one of the coolest jobs I've ever worked at, specifically because I'm learning so much about Kubernetes that I never even thought I would need to know, but I'm learning it. I love Linux. I like to throw Tux up there just because it's one of the coolest mascots ever. I just like seeing him everywhere. People don't realize, like, you got so many devices that run Linux now. People keep saying, oh, this is the year of the Linux desktop, or this is the year of Linux. That was like 10 years ago. Linux has taken over. I started on AWS after reInvent 2014. It's one of the most amazing conferences on the planet, and it just motivated me so much to love AWS that I started the AWS Frederick meetup group. I'm the founder of it. There's a couple of us here, Rory and that high-speed guy from Virginia. Anyway, I'm co-organizer of KeyLUG, co-organizer of the Python Frederick meetup group, and like David, I'm one of the board members of the advisory committee for our advisory board for Tech Frederick, which is a pretty awesome organization. If you haven't gone to any of their networking events, you should definitely go, specifically because you're just going to meet all the cool tech people here in Frederick. So I wanted to start off with what is a container. It's only one slide, I promise, specifically because I want to explain why we're even talking about this stuff. The big takeaway from this is the sheer fact that when you do a container, you get to recover all of this space that's dedicated to the guest OS. Now it does remove some, like, with a virtual machine environment, you can run Windows and Linux machines on the same host. That's pretty nice for flexibility, I guess, for development. But with so many things being able to run on Linux environments now, being able to do that kernel virtualization and recovering all of this stuff, this is arbitrarily big on this thing, specifically because I want to drive home the fact of how much a guest OS takes up of that host infrastructure, that you can recover and run more applications and just kind of make your systems a little bit better. It's just using these built-in things called kernel virtualization that allows you, that uses the user space things. I think it came around originally with Solaris way back in the day. It's pretty interesting. It's been around for a while. Nothing new. So, what are container management systems? Come to find out, I'm doing some research on container, and stop me whenever you have questions.
What did Solaris call their little?
Say again?
What did Solaris call their container stuff?
User spaces, maybe?
Zones. They call
Zones.
It zones.
Okay. Thanks.
Zones was kind of a precursor to like virtualization.
Yeah.
Kind
Yeah.
of weird.
Pretty crazy stuff. Amazing stuff that they figured out a couple of years ago. A couple of years ago, probably like 20 years ago now. So, what is a container management system? It's a lot of things. It really is. It's something as simple as being able to just run a couple of Docker images on your machine, all the way up to something like Google's Borg, which is a system that they built that manages millions of hosts and billions of containers. It's just an amazing conglomeration of things that they built with this Borg. I'm not really going to get into Borg specifically. If you're interested in finding out where Kubernetes originally came from, it's essentially what the Borg white paper is about. But my definition of a container management system, I might have copied this off the internet, so it's probably not my definition. It's just a system that allows you to manage networking between containers and users and data transferring between it, the actual scheduling of the containers, maybe the auto scaling of those containers, deployment of those containers. That's a container management system to me. So the first one that I want to specifically talk about is Kubernetes. It's like I said, it came from Borg. It's their open source components of it that allows you to schedule things called pods, and I'll get into the actual terms at the end of this talk and kind of explain the differences between them. because like Amazon calls them tasks, Kubernetes calls them pods. Why the hell somebody decided to come up with different names for things, who knows? They did it. So, like I said, Kubernetes is the open source version of Google's Borg. It really, as you'll see, I think like the next 7 slides are basically Kubernetes platforms. So Kubernetes has taken over. It's everywhere. It's in OpenShift. Like Rancher uses parts of it. I think even OpenStack has a little bit of Kubernetes things in it. But it's a pretty interesting environment, or platform, so much so that you can do things called Minikube. And Minikube's kind of interesting to me, specifically because you can take your environment that you're building and we can do a little quick demo with Minikube. Minikube is a single host instantiation of Kubernetes. So we can do something like, if we've already downloaded it, Minikube start, and what that will do is actually start up, it's just starting a Kubernetes 1.9 cluster, and it's communicating with VirtualBox that's installed on this. So it's going to stand up a virtual machine. I don't want to show VirtualBox, it's just standing up a virtual machine, and it's going to populate all of this stuff. It takes about a minute, so we'll take a second and answer any questions anybody has yet.
You said this was single host.
Minikube. Yeah.
So that just means you wouldn't use this for production deployment.
Correct. This is definitely for development.
Okay.
The really awesome thing about Minikube is the templates that you use to deploy to a prod Kubernetes cluster will work on this. Now there's going to be some differences. It has the ability to do load balancing. Doesn't work, at least in my experience, doesn't work the same way that it would in a production cluster. In my test here, we're going to do an exposure by a node port, which I wouldn't necessarily say you should use in a production cluster. So there are some differences, but as you'll see here in a second, you can accomplish a lot of the same things in dev by using Minikube on your local machine that you would get on a prod Kubernetes cluster. So you'll see here, I just did Minikube start. I started up this instance. We can do a kubectl run Minikube image K8s. I'll talk about this in a second here. So kubectl is the command line. If anybody's done anything with Vagrant, kubectl is kind of like that. There's a lot of different CLI commands that are out there that you'll see are not, what's the word I'm looking for? Not, it's in my brain. There's some similarities between kubectl and other command line utilities like AWS command and some other things that you'll see with kubectl. So we're running kubectl with a run command. It's kind of like Docker run. We're starting a container that we're going to call hello Minikube, and we're pointing it at an image repository of K8s, which is K8s is the short form, maybe slang of Kubernetes, because Kubernetes is a really long word that nobody likes to say, so they say K8s. GCR, which is Google Container Repository, I think, .io, and then we're starting a server called Echo Server 1.10. That doesn't really necessarily matter. We're standing up this server called Echo Server, and you'll see in a second, Echo Server, when you curl against it, it just responds back with information about that curl.
Is there a big repository at that of applications then?
Yeah, there's obviously Docker Hub has a lot of that stuff. Kubernetes has a bunch of their stuff that's open source that they have out on their own repository.
Like CoreOS plays. There's like a lot of.
Yeah.
What's the page that sort of lists the name of those repositories?
I don't know off the top of my head. I know you can go to Docker and find a lot of them.
Docker.io and find stuff.
Yeah, you'll see in my other demos, I'm gonna, instead of using Echo Server, I'm gonna use Nginx, and it's just the public version, the public official version of Nginx that's available. And
so I mean, people posted it's like a ton of applications for network testing
Yep.
and all kinds of stuff.
There's, I would say there's a lot of things that you don't necessarily need to worry about building yourself. Now you do have to worry if you're going to pull in a public image, you probably want to know where that image is coming from. But in this particular case, Echo Server is no big deal. The official repositories like Nginx or the Ubuntu or CentOS images, those are official, produced by that organization. Usually on Docker, they have a little like official badge tied to them, so you know that they're official. And so you're not just pulling like Patrick Pierson's version of Ubuntu that exfils all your data to my personal S3 bucket. You know, but I'm happy to give you that link if you would like it. I'm joking.
So is this just downloading the binary and running the binary, or is it downloading?
It's running the
code?
image. It's running the image, and the
Yeah.
image is in itself a mixture between a gzip, or I guess a tar, and a gzip version of the code, plus some extra little things that Docker or CoreOS does to ensure the image's stability, tells it how to start. There's a lot to it.
Is it available to unwrap and look at the code?
Sure, yeah, probably.
I mean, in the container that you pull from down.
I'll be 100% honest with you. I don't know all the details of being able to break apart a container.
Associated with that. And
Well,
sometimes
so-
you can remote shell into the container, just walk the
Yeah,
file system.
you
and
can
look.
do that.
That's what I'm asking.
You may not know exactly how it was built. So one of the things that Red Hat does, I'm not going to hijack this, but we have a registry.access.redhat.com. We provide graded container images. So if it has a grade of A, there's no known vulnerabilities. If it has a B, nothing's greater than 7 days. If it has a C, nothing's older than 30 days. So one of the challenges with Docker Hub or some of the public ones is there's no provenance. So you don't know what decisions were made when that image was produced.
Right.
So there's a real trust issue with using public repositories. Now, if it has a like you said, if it's the official Ubuntu image or the
Then you
official
know where it's
Fedora
coming
image, and Fedora was the organization who produced it, you probably have a higher level of trust than if it's Joe Blow's Hello server or something.
Well, then
I would
all
say,
the-
real
yeah.
quick, I would say a lot of those questions are probably better answered by a containers talk, less of a container management systems talk.
Yeah.
I'm happy to talk about that after I get through all
Oh, I
this,
see.
because I've got a lot of stuff to talk about for
Okay.
container management
Go ahead.
systems, not so much just containers themselves.
Okay.
So I hate to cut you off. I want to make sure that we stay specifically with container management systems, because we've had other talks. We could definitely have more talks about containers themselves.
In the future, we definitely will do that.
Definitely, yes.
We
And
can't-
like I said-
you can't address everything in one meeting. There's no
Right.
way.
I'm totally happy to talk about it after we get through this whole conglomeration of craziness that is the actual management systems themselves.
And I would add that the Kubernetes is flexible where you're fading out. But Kubernetes is flexible that it can work with multiple container engines. So you
Right.
don't have to worry about necessarily the
Right.
container engines you're using in the engine.
Right.
It's pluggable.
So like we're doing here, we're just running a very simple Echo server called Echo Server with the Minikube version of Kubernetes. So it creates it, and just while we let that spin up, we can look at kubectl. And like I said, there's just some fairly simple things here that it does, like it's pretty big, so let me. So there's simple things like create, expose, run. All these we'll get into in a second. But like I'm saying, it's just it's a very simple Kubernetes command line. So we started the actual Hello Minikube container. If we take a look, we can do get pod now. And like I said, a pod is either a single container or a conglomeration of containers that provide some sort of service. So here we see the Hello Minikube pod itself, and it says it's ready, it's running, it hasn't had any restarts, and it's been up for 60 seconds. So we want to make sure that we expose it. I wish it would do like auto-completion, because auto-completion command lines are the coolest, but it doesn't.
Well, with Google Cloud, right? On G Cloud,
So-
Kubernetes, that would happen.
Thank you for ruining my slide from 2 slides from now.
It's only a teaser for the next.
Surprise!
So here's the kubectl command. We're now exposing the deployment of Hello Minikube to a type of node port. There's a big difference between node port and load balancers, in the sense of load balancers behind something that allows for multiple containers to be served by a single endpoint. With a node port, you're exposing it on a single node, and I'll get into it later. A node is an individual host. And so this single Hello Minikube is being exposed on this single host on a specific port. Obviously, that's not scalable. That's why in a production environment, you would use a load balancer.
You're exposing everything on that pod, right?
Well, it's just the single port that we exposed earlier from 8080. Did I run? I didn't do that, did I? Thank you.
Did you assign node
No.
port to 8080 there?
You are correct. So let's go ahead and thank you. CTL, delete, is it? I think. Hello, Minikube. I have it written down. What is it? Delete.
Then
Yeah, okay. CTL. Delete.
If you go to resources.
Ah, thank you. Resource. It's, is it a deployment? There we go. Okay, let's start over. Minikube. So let's do this again. We're gonna run this.
what does the deployment function actually do?
Let me finish the command so I don't screw it up again, Glenn.
Deployment is the type of object within Kubernetes. It's not a function. So you're deleting that object name.
All right. So this run command is creating a deployment, and that deployment is specifying a set of containers, or in this particular case, a single container of Echo Server, and we're saying that we want to deploy it when we run it as a service on port 8080. And so that's just, that whole command is just saying that here's the container that we want to run. We know we want it to expose on port 8080. We're only going to expose it on port 8080. That's what's going on there. That's what that deployment is that you were just asking about, that I so rudely cut you off from. So now we can run our git pod. We see that it's running as of 7 seconds ago. Now we can run kubectl expose deployment hello minikube type node port. Now we're doing that same. We're taking that deployment and we're saying we want to expose it on, in this particular case with Minikube, this single host that it has available as a type node port. And it'll come back and it'll say it's exposed. Now we can run this command. This is just inside Minikube because we're, like I said, we're running Minikube outside of, it's doing the Kubernetes things. Minikube has some built-in things that we can say.
So question, I notice it says deployment hello minikube created, and then it says service hello minikube exposed. Now, does that just relate directly to that image?
It's related to that deployment.
Okay.
You can do a cube control at all, just to show them all the different objects. And then maybe scale that down.
So there's a lot of different things that it's doing here. There's the Hello Minikube that it's started up as an actual deployment. There's actual services that it's done. What else is it doing there?
So there's a, so the thing that he deployed, this describes what the deployment is.
Okay.
This is a replica set, how many
Alright.
copies you want running. Actually you have multiple, and then here's the pod that's actually running. This is wraps the container image. This is what gets scheduled and run. And then services are how you expose
Right.
the thing so that external users can find it. So one thing to understand, I think that'll help, Kubernetes is a very desired state listener controller type architecture.
My plan is to talk about all of that when I get to the Kubernetes engine.
Another
because-
teaser.
Because
But
when
the
this
goal
is
here is
all-
there's lots of different objects that are managing your application that
There-
you're creating through that API.
Okay.
So what I'm about to show is the Minikube dashboard, which I think actually probably does a little bit better explanation of all the things that you're looking at here compared to just looking at the command line. We'll get to that in one second. I really hate to cut people off. I have things in a scheduled way that I like to show it, and it will answer a lot of people's questions if you just let me get to it. So we've exposed this thing. We can now say, so it was, let's see, Minikube service, hello Minikube -- URL. this is using the minikube command line to just give us a HTTP endpoint that we can now curl. If we encapsulate this, we can.
Where did that port come from, Patrick?
So that's the node port. Those are so the reason that node ports are not very good for production environments is because that's randomly generated, and it's more of it's being exposed on that port, and it's not being Kubernetes created that port. A node port gets exposed between port 30,000 or 32,000 and 33,000.
Do you have a way of determining that ahead of time if you wanted
No.
to?
It does it on its own.
And it reserves that port across all machines in the cluster
Yeah.
for Kubernetes. So the reason you want to do this is if you have something that's not an HTTP endpoint or not an HTTPS endpoint, you need to put a reverse proxy in front of it. So if I want to expose a database or something like that that has a specific port to connect to, I can use node port. Node port is reserved across all instances of my cluster. Any node in the cluster that you hit on that port, you get redirected to the layer.
So you have to configure all this before you do anything to take advantage of it.
Yeah, but it's not, I mean, it's fairly obvious. You just have to know what the numbers are.
So we'll hit this, finally this service is up and running, we're able to run this curl command against it. And it's just responded saying, hey, I was able to curl that Echo server endpoint, and it says, okay, it gave us back some information. Fairly simple, but to get to what I was saying with Rich there's Minikube dashboard, which Kubernetes itself does not come with this pre-installed. You have to say Kubernetes run the dashboard, and it runs a dashboard container and presents this to you. But this is a pretty good explanation of a lot of the different things Kubernetes does. So inside the cluster, you've got these namespaces. So you have like a kube public or kube system. And these are reserved for the Kubernetes system themselves.
Could you zoom in a little bit?
And then the default namespace is where a lot of the things that you're going to stand up. But this allows you to have like a multi-tenancy type thing where you can have different namespaces. So Rich can have his namespace, you can have your namespace, I can have my namespace. Our things, if you don't want to spin up individual clusters, you can have them inside of namespaces. And also maybe if you want to split it off into different types of services that are available, that's all possible. Then we have nodes, and in this particular case, we have just the Minikube node. But then it gives us all this information. We can see a lot of the different things. And there's a lot here that you don't necessarily care about. Maybe there's some stuff there that'll help you figure out some things. But it's just a nice little visual representation of the Kubernetes cluster.
One thing that helped me, I think, get my mind around all of this is if you think of the Linux kernel managing resources on a single box or a single server.
Kubernetes doing it for everything.
Yeah, Kubernetes is like a data center operating system.
Yeah.
So if you look at the things that has cron jobs, daemon sets, all of these things map to concepts you're familiar with just from an operating system level. So pods are the processes you're running, and here's all the stuff that helps make it.
So under pods, which I was getting to, Rich.
Hey, can I ask you a question?
Keep people in line.
Go ahead.
I'm sorry. I'm just looking at discovery and load balancing down there with ingresses, and I'm wondering, like, if we wanted access to like layer 5, 6, 7 stuff from like an application load balancer, what is the endpoint that we would put behind the load balancer? Is there like an endpoint?
What are you talking about?
Like if we were doing this in the cloud or something.
Yeah. So like with Kubernetes, and if you were to do it inside of Amazon, Kubernetes will actually stand up instead of like on Kubernetes Engine. With Google, it'll stand up just a service load balancer inside of Kubernetes. It's like an ingress mixed with like maybe like an Nginx container that's doing the load balancing of some sort.
Okay.
On AWS, Kubernetes has the built-in setup for API calls to stand up like elastic load balancers and application load balancers to present, and it'll stand up those resources inside of AWS for you. And then it will then also tell those resources, hey, here's the target for like an application load balancer. It'll tell it to talk to this target on this machine, on this port. It'll do the work to update those load balancers.
Gotcha.
I don't know if that answers your question.
Yeah.
But I guess the answer I'm going for is,
You
at
can
least
use
on
it to call
AWS,
API.
yeah, Kubernetes has the code built in to stand up those AWS resources instead of standing up the resources inside of Kubernetes.
Okay. Yeah, that makes sense.
Yeah. Now it does have the capability to do that. Like I think it's like Kube on Metal. It'll stand up those load balancers as pods themselves, and allow. And maybe there's some other things in there like Kubernetes. I'm not going to get into it today, but it has like a thing called ingress, which the actual Kubernetes thing is presented to you like we can access this. It is non-secure, but this is the Kubernetes. Really, on the other side of this is the Kubernetes API, and so you're able to get a lot of information about your Kubernetes cluster just in like some sort of JSON format. There's also on that same API the ingress thing, so you could, if you exposed it via an ingress, it would be available via the API. It's only available on either 80 or 443, but it's the web endpoint that you are presenting from your container through the Kubernetes API.
Okay.
So like Rich was just saying, we can look at pod information. We can even pull up the logs here, and we can see that we hit that endpoint there, just to prove that we do. I just hit it. Oh, that's not what I wanted. Let's go up one more. So we just curl this endpoint again a few more times, and we can see these logs getting updated. There we go. Where's the refresh? No, hold on. That's the wrong button. There we go. And we get it a couple more times. That's pretty good. That's just allows you to run Kubernetes on an individual instance for your local development. So, on a larger scale, Google has their Kubernetes Engine, which is a managed Kubernetes cluster by Google. To be completely honest, I know I'm an AWS nut job. This is actually super simple. You'll see here in a second I demo it. It's probably one of the easiest things I've ever done. What's really interesting about GKE is there's no additional price for GKE. The cost is per instance that you run inside of your cluster. So you'll see when we start it up, I'll specify a single instance. I will be paying for that instance, but I'm not paying to run Kubernetes, and that's important because you'll see, I believe, a flaw in the Amazon implementation here in a moment. So for the GKE demo, let's go ahead and look at Kubernetes on Google Cloud. So we have the Kubernetes engine open. We hit create cluster, and we're just going to call it cluster 1. I know this is super zoomed out for those back there, but it's just like some very simple Kubernetes things. We can give a description, zonal or regional. That's just basically if you can spin it up the same way Amazon has different regions and then zones within regions. Google and Azure have the same thing. It's not a new concept. It's just there's zones inside of regions. In this particular case, we're just spinning up inside of a zone. I don't think there's a huge difference.
Did you select the service, Kubernetes service inside of the service of Google?
Yeah, so in fact, we can go back. So if you look here, you've got on the left-hand side here all the different services that Cloud Platform has, and we have Kubernetes in it.
Okay.
And then we can hit create cluster. We're just going to call it cluster 1. We're going to run it on 197. Let me zoom in just a little bit for folks back. Okay. 1 VPC. We can specify all the different instance types, everything you want to do. You can customize with this. Just to save me like 30 cents, I'm going to set it to 1 because you pay by the minute, or maybe it's by the second in Google. And if I'm only running this for 5 minutes, I think my bill last month, because I was demoing all this stuff to myself, was like 30 cents. It was pretty
If we put more than 2 or more CPUs, does it split a worker node up in each core?
So this is specifying the actual machine type. And so these are just different types of machines that they have available to us.
Right.
That is something that's handled by the actual virtualization what you're talking about
Right.
for the
Configuration.
pods, that's handled by the workload stuff that we'll get into in a
Okay.
second.
All right.
So we're just specifying one instance. We'll go down here and create. This whole thing takes maybe 3 minutes, maybe. We'll see here. This will be available for us to connect to here in probably about 2 minutes. So it's still standing up. We can hit connect, and what we can do is, Rory, as you rudely ruined this slide.
I'm mouse up for the rest of the presentation.
What's really interesting, I really want AWS to do this, is you can stand up a Google Cloud Shell machine. I don't think there's any additional cost. Maybe there's a cost. Like I said, in the demoing that I did to myself for this, my bill last month was 30 cents. So
For this machine?
no. For all of the demoing that I did for this talk, which was running through this like 5 or 6 times,
Oh.
my bill was 30 cents.
So like 5 hours?
Probably. Yeah.
Okay.
Super cheap. Maybe I'm still in maybe a free tier or something. I don't know. I don't think they have a free tier. I know my credits.
Well,
are
actually they
expired.
do. I got a $300 credit. for
Yeah,
Google
but
Cloud,
I know
so-
for a fact that my credits expired like 2 years ago. So, anyways,
Right. But yeah, you should be able to sign up because I just had a coworker.
no.
sign up.
If you already got the credits, they won't give them to you again.
No, if you're new, if you sign up new with the Google Cloud,
Right.
you should get $300 credit.
Correct.
So go do it. They're like, get your $300.
It's a whole lot of Kubernetes.
Yeah.
Or well, I run 100 and something core machine, so it's like $3 a minute. So it's
Oh.
I can't leave it running very much.
So we're just letting this thing finish spinning up.
No.
It'll be up here in a second, and then I'll be able to show you the same kubectl commands that we
Yeah.
could run on Minikube. We can run on this same thing here, but I'm not going to actually do the kubectl commands. I want to actually use the CL or the console, the web console, just because you'll see it's pretty simple. This stuff is not rocket science.
When you're on Google, Patrick,
Is that?
when you're on Google, where do you run the kube control command from? Is there a host or something?
So this is what you're looking at here.
Oh, what'd you call
If you,
that?
if you take your sunglasses off, you could probably see it.
Oh,
I'm
I
just
need it
messing-
so I can see it.
just messing with you. So no, it's just they had this connect button here, and it says run in Cloud Shell, and it popped up.
Okay, good.
It popped up.
So you're
this here.
SSHing through the browser?
It's a Cloud Shell. Who knows what it's doing? All right, so there. So this popped up. This was a command that it automatically came up with. It's just a gcloud command that's pulling the credentials for this cluster 1 that we just started, and it says, hey, we'll update the cluster kubectl command, so we can now look at kubectl. We can get cluster. No.
So kubectl is just basically a client, and then the kube API is getting
Yeah.
managed everything. What are they using? Using gRPC?
No.
No, it's
So-
REST endpoint.
Oh, it's just REST.
In fact,
JSON.
kubectl is just talking REST JSON
Yeah.
to the server.
So
So
this,
you can write your own.
I did just a kubectl cluster info just to show that there is a Kubernetes thing that's out there that we could interact with via kubectl if we wanted. But in this particular case, we'll just use the Kubernetes engine because it's pretty well established of being able to just click some buttons and you've got your service up. So this workload, same as the, if we looked at the kube dashboard, which I closed out already, the Minikube dashboard had workload that you could start up. This is just being able to stand up that containerized application. So we'll be able to just, it defaults to Nginx latest because we just want to set up an Nginx container. All this stuff is fairly, you can get way down into the weeds if you would prefer, but you could set up environment variables, you could specify a different command than the actual Docker run command that you specify. With Nginx, it's a command that just starts up the Nginx container. We'll call it Nginx1. We'll keep all this defaulted. We are specifying the cluster here We'll hit deploy, and it's just gonna create a deployment like we did with the Hello Mini Kube. In this particular case, it's doing it through the console and it's doing it for us automatically. It's making those API calls to our cluster to say, we want this, this, and this stood up in this particular way. We could do this inside of kubectl, like I said. The reason it's saying pod error is unschedulable is because it's, by default, it's trying to stand up a replica set, as you were saying, of 3. There's not enough resources on a single host, so it's really only going to stand up 2. So you see that it was able to stand up to 2, and one of them was unschedulable. It's perfectly fine. It's a replica set. If one of those is down, there's still 2 left to serve up things. So it's a replica in the sense of there's multiple things that are available now to interact with. So that's up and running.
Is it one container with 2 sets, or is it 2
It's 2 containers in a replica set. And so that replica set is doing the work to ensure that that thing is always available. Now, in a production environment, if you're Netflix, your replica set for a specific service may be 1,000, maybe 10,000. It's all dependent upon the amount of load that it needs to handle. Does that make sense?
Do you put separate replica sets and load balance the 2 replica sets, so for example?
I don't know the answer to that. I would say no, specifically
Well,
because it's a single replica set that's doing the work to ensure that the number of
Containers live in pods.
yeah.
Pods are what Kubernetes gives you. And then when you replica set, you're creating a round robin connection to those pods. So requests to those pods just get shared across all those. You can, in fact, put a load balancer in front of that.
Correct.
Right, but if your application work inside the containers had, like you had one really intensive set of applications that are in a set of containers and one light.
Well, that's where you would have 2 different replica sets.
Yeah, that's
Are you
what I'm
talking
asking.
about, you would have, like, let's say we have an Nginx container that's running the WordPress
Yeah, database
things,
versus
and then you
something like-
have the MySQL database.
Yeah.
Those are 2 different replica
Right.
sets.
Yeah.
So does a replica set work across nodes, or is it just specific to a node?
It works across.
It's across the entire cluster.
In fact, you really, as a deployment developer, you don't care.
Yeah,
You don't care where this is being scheduled. It's just going to run.
whether or not it's up.
It treats your entire data center as an operating system.
Yeah.
So your job, your pod is just a job somewhere running in that
Yeah.
environment.
So these are up. We can go to services, and like Rich was just saying, we can actually, not service, we go to workload, and we can specify that we want to expose this Nginx workload. We want to expose it on 80, and we can specify here a load balancer. You see the different things there. A cluster IP exposes it on an internal IP to the cluster. That's if you're you wanted to expose behind some sort of round robin thing, but only internal to the cluster is a cluster IP. Node port exposes it externally on an instance, but it's going to only be on a particular instance, and then a load balancer actually creates the load balancer to load balance to the various containers. We're going to do it with a load balancer, and we'll hit expose. It stands up a load balancer service per se, and says, okay, we're going to put it to this specific set of containers.
So does that spin up another node? I mean, not another node.
Another service?
So on Kubernetes Engine, it's not standing up another service. It's doing the work to create a load balancer within Kubernetes. In AWS, when you do that and you stand up a load balancer, you're standing up the actual load balancer inside of like Elastic Load Balancer. With Kubernetes, it has built-in capabilities to do some load balancing.
Do you have the option?
What's that?
Does Google have the option of doing external load balancer versus internal to the cluster?
Well, so that's the difference between, at least how I understand it, a cluster IP and then a load balancer. The cluster IP is
Internal.
internally a load balancer to the cluster.
Okay, gotcha.
And that's where you would, like, if you have like a database stood up internally, you could do a cluster IP, or if you have an internal service only that's maybe doing some processing or post-processing of like maybe uploaded images, you don't necessarily need that exposed externally, but you need it to be able to bounce around the cluster. That's where you have a cluster IP.
Each pod gets a unique IP address, but that cluster IP is stable across your service. And it's not an actual IP, it's more of like a redirection via IP tables. So when you need to contact a database pod running in the cluster and you don't know its specific IP, using the cluster IP redirects you to where it is.
Yeah.
So it could be running on any node in your cluster, and it'll always find it.
Yeah.
And the cool thing about this too is if you just pull power on one of the pizza boxes in your data center, take out a node,
It's going to rebalance it all.
yeah, it'll discover that and it'll fix it. Then you bring it back up based on replica sets. So if you say you have 3 pods need to be running, it'll run them somewhere else.
So our load balancer is up.
Self-healing.
Of course, it's up and not responding, so that's sweet.
Well, your app might not be ready to do it.
It said it was.
So, is there any type of DNS, internal DNS to Kubernetes?
Yes.
Okay. So it looks kind of like just like a regular Docker network in that sense.
That cluster IP has a name associated with it. It's like service cluster local or something.
Okay.
Is the domain name, but it's all local to the cluster. It's not shared out.
Yeah, yeah. That makes sense.
It's kind of interesting. It stood it up on port 79, even though I told it 80. I don't particularly know why I did that. So let's just delete it and start over.
And then one thing to keep in mind too is that everything can get another level of ridiculous abstraction. So the next thing coming down the pipeline is Istio. Istio is a service mesh that overlays Kubernetes that allows you to do things like if the client's using a certain type of browser, route to these services. If they're using a different type of browser, route to these services. Have very complex selection logic beyond just a simple load balancer or routing technology like a.
It seems like that would open up a whole slew of other problems.
I mean, it's what they're
Don't get me
talking
wrong,
about. It
I
gives
get
you
it.
tracing and all kinds of things through your system when you're running, doing multiple microservice calls and things. But it just adds more indirection and complexity.
So within the cluster though, doesn't each like node have to have like its own SSL certificate or its own security or
No.
how does that work? I mean,
So you can do termination at the load balancer and then do plain text to the.
So in this demo, it's all plain text. We're not even
Yeah.
talking SSL yet.
You can do.
But-
you can do decrypt, re-encrypt, or you can do a pass-through. So you can do a pass-through. The load balancer could pass through SSL connections to one of the nodes, to the pod, but the pods are going to have the same certificate shared amongst them. And there's ways to assert that. It gets down in the weeds a little bit. But you can use secrets to inject things into pods.
right.
At
Right, you have
runtime,
to
that do
handle
not
it
exist in
somehow.
the image. Right. So you're creating file mount points at runtime that don't exist in your image, but it looks to the system running in a container that there's a file there that is always there.
Right, but within the pod, like there's multiple nodes. Is that accurate?
No. A pod can have one or more containers running inside it.
Yeah.
Right, and so those containers, when they speak to each other, how do they communicate?
Inside a pod, they can use localhost or shared memory.
What does that mean?
So the pod is assigned a single kernel network namespace, meaning the pod thinks it has its own Ethernet device, but it's virtual, and all containers in that pod share that Ethernet device. They think they have their own file system and they're isolated, but they're actually able to talk to one another via local host, like 127.0.0.1, and they can use shared memory to talk to each other. So if you want to allocate shared memory segments, if you need to do that.
So I don't particularly know why the first service didn't work, but deleting it, restarting it, or deleting it, recreating it, got it working perfectly fine. We have now an Nginx container behind a load balancer inside of Kubernetes Engine. Like I said, pretty simple, super easy.
Why is everybody using Nginx now?
Because it's faster than Apache.
Easier to configure, just has a lot of some
So-
more recent. Actually, I have a really cool Nginx shirt. I should have worn that.
Nginx has
This is my Openshift shirt.
Nginx is
Appropriate for
Dude,
the
all of a
just
sudden
seem
it
to-
came out of the weeds now after.
they,
been around
they,
for a while.
they have a really good marketing team, truthfully. Like I believe that's the case. You know, Apache, don't get me wrong, Apache does a lot of good things for the open source community. But if you're able to give away really awesome t-shirts and you have really awesome people to talk to and your service is faster and easier to use, then it's gonna be.
Is that a California startup running managed services?
Oh, sure.
They have Nginx Plus, which gives you some things over top of Nginx, and you pay for that service.
This is the Red Hat model.
Hey, we wouldn't be here today if it weren't for Red Hat, truthfully. Like,
They actually-
Linux would not be what it is
I like
today
the
if it weren't for
business
Red
model.
Hat and stuff like that.
A lot of
Because you
people
gotta
come.
realize, there's people that can talk about this stuff, But then when you get into situations in enterprise where you've got people that say they know what they're doing and then they don't, you can go to Red Hat and those are the guys that wrote it and they're able to make it happen.
You know,
It's
it's
a good
funny,
business
like,
model.
I was talking to some of my colleagues, the technology treadmill is just so relentless and everything's changing every couple of years. Like, there's some JavaScript framework I didn't learn 5 years ago, and it's okay because no one's using it anymore. It's like completely replaced with something else.
So
Yeah, I mean, I got 30 years of books and I just gotta keep throwing them away because it's no good.
So like I was saying, Kubernetes is kind of everywhere. Amazon has a elastic container service for Kubernetes now, EKS. Truth be told, I haven't used it.
I have.
It's probably pretty good. Like I said, there is this little thing that catches you. We're on Google Kubernetes. You just pay for the nodes. With EKS, you pay 20 cents per hour to run the cluster and then also for the instances. So you're going to be paying more just to run on Kubernetes on AWS.
Just a short note on, they've actually deployed it, and the EKS service just sets up the master nodes,
Yeah.
but you have to manually set up the kube control, you have to set up the cluster
Yeah.
manually. So
Yeah.
there's, right now, there's a lot. The Fargate is coming down the
Well,
pike, which hopefully will be more.
Stop ruining my slides.
Oh, I'm
Can
sorry.
you still shut off the 20 cents per hour after you shut your instances off? Can you shut the Kubernetes service so that's not kicking away?
I haven't stood it up. All I know is to run EKS, you have to pay 20 cents on top of paying for the actual
Okay, well, you don't know
instances
if you can
inside
shut
of
it
the
off.
cluster.
That's kinda-
You can delete it, and if you're
Well,
building
no,
your
but-
environment to be scalable and to be redeployable, like if it's a test environment, I think at the end of the day you should delete your environment
And
and then
redeploy
in the
it.
mornings stand it up.
I've had the issue with AWS and niche generally that I thought I deleted everything, but I still got to build it.
There's services that
I know.
kill things.
You gotta like go deep into the weeds to find it.
I think there was so much interest in Kubernetes that
They had to, and it
they
was
had to release something. So
yes.
they call
Because-
they call it GA, but it's really like 0.9.
Because Azure also has a Kubernetes service. I don't know anything about it, but there's a no additional price to run AKS. You do pay for the actual instances. So Google's Kubernetes and Azure Kubernetes, you just pay for the instances. AWS, you pay for the instances plus running 20 cents per instance hour for the actual cluster itself.
Yeah.
The ultimate answer is whatever cloud you're on, you can let them manage the Kubernetes cluster for you. If you're on AWS, you pay 20 cents extra an hour. The idea there is you don't have to worry about running the cluster. You just push some buttons or run some commands,
One thing to say
and they'll
about
let
this,
it run it for you.
Microsoft has made a lot of investments in Docker and Kubernetes technology, so
Yeah.
it runs on Windows.
Yeah.
So they do offer Windows nodes capabilities
Yeah.
here.
That's
my,
it. That's
my initial the feedback I've gotten on that is those images are huge. So Microsoft, if you look at Kubernetes and Docker, everything's based on Linux technologies, C groups, SE Linux policies, namespaces. There's some analogs in the Windows world for those things, whether they're as secure or equal is,
Left to be said.
Yeah, left to be said. And the DLLs that they package with their images, each image is like 10 plus gigs, like they're just gigantic. So,
Wow,
yeah.
that's huge.
So, closing out at least the Kubernetes side of things, there's also OpenShift. And I do have a mini demo of this, but I definitely I'm glad you're here. I want to rely on you, Rich, just for some input of things that I might miss. But it's
When you
pretty
say
interesting.
10 projects for $50 a month,
Next slide. I'll show you.
There's some OpenShift Online is just one option.
It's-
you can use.
It's the one that I'm going to use is OpenShift Online. It's pretty interesting, but it's another container system that allows you to very easily stand up some stuff. So
There's also Minishift. It's similar to Minikube, but it runs OpenShift as a single VM laptop.
OpenShift's a lot more than just.
you have to run CentOS or Red Hat, or can you run
Running
it
on
on
Mac.
it's
I have Minishift running on Mac right now.
so
just native on the mainline?
Well, it uses VirtualBox like Minikube.
Okay, virtual.
so we have I've already created my project, but you just when you log in, you create a project, and it comes up here. And what I really liked about OpenShift over the other things was instead of worrying about standing up the what you've noticed from the other things that I was looking at, it focuses on standing up the pod, whereas this focuses on standing up the application. So we can very easily.
Is this just a free? I mean, Rich is
This is-
probably gonna be. This is just a free OpenShift, like you log in.
Yeah,
with a
so
free OpenShift account.
you get one project free in this version that I have, or this billing version that I have. So I just created a project, and we'll just create a Django Postgres application here.
So you can run a website database free then on it?
Yeah, so I'm clicking next, and you'll see that it's going to stand up Django and Postgres. It's just, just very simple configurations of things. I'm not going to change any of this, but you can specify some things. This is all within the free tier for this account, so it's pretty.
So what's going on here? Scroll up just a little bit, just quickly. This Git, or go down just a little bit. There was a Git URL. So OpenShift doesn't force you to have a pre-built image. It'll actually take source code and assemble the Docker image for you. So it has what are called source to image, or these builder images, all those templates that he was just showing you. So it just automates all that.
Yeah.
I think the key difference between this and the Kube distributions is that OpenShift finishes the job. So if you want to do log aggregation, metrics collection and aggregation, security, things that help developer productivity, all those things, Kubernetes doesn't include any of that. Kubernetes is the operating system for the data center, but there's a lot of stuff you got to layer on top of that, a lot of choices you got to make on how you're going to build that.
So I just went ahead and clicked next. It's going to create the Postgres container and the actual Django persistent container.
You go to overview and see that stuff that's coming up all the
I wanted to actually pull up the Postgres container and actually look at the logs, because it'll actually watch us. It'll tell us that it's standing up the actual Postgres container. Hopefully.
Yeah, it just has to pull the image. See it kind of. If you go to overview, you should be able to see a solid.
There we go. So here you see it's standing up a Postgres container. It went out there and it pulled in, set in some passwords. It's all like Rich was saying, it's all pre-configured. Should already have a Postgres instance up. Yeah, and I think we can now go to services. You notice some of the same things here: deployments, pods, services. Not entirely sure why that's doing, but it shouldn't matter because
Running again.
Patrick, where is this running?
what's that?
Where is this OpenShift running?
So OpenShift Online, I think we as Red Hat hosted on Amazon.
I'm in
certain
CA
about that.
Central 1.
Yeah, it's in some public cloud somewhere.
Okay.
It shouldn't matter.
So we have ourselves a persistent Django instance that we can now connect to. It's not up yet.
It's not yet ready.
It takes a moment.
If you go to the overview and they go solid blue, they're ready to go. So if you see the Postgres as a solid blue circle, if you expand that Django, you see the other one. Expand the other one. See what it's doing. So it's doing this crash loop back off where it waits and then it tries again.
Yeah, it's just waiting for the Postgres container
There,
to
it's
come up.
right.
Right? Perfect. And we have our.
Give it a second. So this is the difference between health and readiness checks. So it might be running, but the system itself hasn't fully initialized. So when you try to access it, it's not ready to serve requests. You can look at the log.
That's good to know because someone might think something's wrong when it really isn't. It just needs more time to finish establishing itself.
I'm not sure what the key message is that you're looking for to start up with Django, like when it's ready.
Well, so what I was thinking was when I've seen this waiting a moment to come online, I was actually thinking that the reason it wasn't showing, it was saying application not ready, is I was thinking the actual API redirects weren't finished populating the point to this.
If you go back to your log, it was doing health checks.
Right. No, I understand that.
Yeah, yeah.
The our application was up. The actual OpenShift API hadn't finished doing the redirects to this.
No, it's usually that the application's
Okay.
not ready to serve
Okay.
requests. That's really what's happening.
In any event, our Django app with a few clicks of a button inside OpenShift is running. And it actually
that's
goes
really
into
a Postgres database though, right? In the container.
well,
and
it's
the
its own
Django.
container.
What?
It's its own
Postgres
persistent.
is in its own container.
It's its own container and you have another container with the Django?
Yeah, and Django's able to find that Postgres
Right.
database based on
So
the configuration.
they're running right next to each other.
You might
They're
be able
see
to,
each
if you
other.
click on the Django, you might be able to look at its deployment, see like how it's talking. Like look at the environment, maybe there's some settings there on how it's, yeah, so it
Yeah.
has some settings on where to find that database.
What
Is
I
it-
what I
is it-
think is pretty interesting is
Is
we
it
have
kind of a full, like, okay, so compared to say Red Hat running Postgres, is it that database the same in terms of
So-
performance and capability and version?
what we have through this, we also have our storage section here, which that Postgres is getting set there, and it's a persistent volume. So you would think, like, I'm always against running databases as containers, but we're getting this storage capability added to the container so that if we were to destroy that Postgres container, we still have the storage saved off. So even though it's a container database, we have some persistent storage available.
I would caution you one thing though, like if he goes back to the overview, you can spin up the number of Postgres instances, but don't do that just, arbitrarily, because that may not be a proper configuration for
Yeah.
Postgres, and you might get lock contention in it. So some of the vendors that we work with have recommended deployment architectures. If you want a truly scalable database running as containers, we have separate, vacuum processes and log and transaction management.
What I do specifically like about OpenShift, what I was kind of saying at the beginning, is OpenShift seems to focus more on the applications, less on the running of the containers, specifically because you can see that in this basically start guide of the Django application. It talks about how to update the Git repository so that OpenShift will see those changes and automatically deploy them for you. So you're not even worried about standing up the pods or standing up the services. OpenShift takes care of all that. You just deploy the code, and it's
If you go back out, there should be under builds, there should be like a pipeline option. Like if you go all the way to the left, builds, pipelines. So you can create Jenkins pipelines. Jenkins can run inside OpenShift. And like he was saying, if you have webhooks configured, your development team, if they push a change to the source repository, that's sufficient to trigger a build and a deployment within OpenShift. And then in these Jenkins pipelines, you can have decision, should you promote or abort based on how the tests were run and what the outcome was. So you can configure tools like SonarQube and all kinds of stuff to do.
Quick question.
Yep.
So OpenShift can be multi-tenancy, or do you run one?
per project.
Per project? So if you have one project, you stand up a cluster for that project?
Yeah. And then, so I'm gonna
That's cool.
I'm answering your question for you. In the sense of, it's dependent upon how you want to do it. So if you stood up your application and it's internally multi-tenancy, that's on you. If you're interacting with multiple customers for the same product, you would obviously stand up multiple projects, and that's how you get that multi-tenancy. OpenShift is like Amazon. It provides you an account and says, here's your resources, do with them as you please.
Okay.
The other thing I would say, one of the benefits to this is what's your off-ramp from the cloud. So if you run OpenShift on Amazon, if you run OpenShift on Azure, if you run OpenShift on Google Compute Engine, if you run OpenShift in your data center,
It's
run
the same.
OpenShift on your laptop, run OpenShift on some dedicated physical box, the apps you create and the templates that describe them are deployable across all those environments without change.
Yeah.
So you have true portability. And what we often say is AWS, GCE, they all offer these great services. Azure offers these great services.
But you're locked into that
But
cloud.
you're locked in. And if they're not a favorable rate for what you're trying to do, then
i.e. paying 20 cents extra to run Kubernetes Engine on Azure or Amazon. Yeah, totally. Rancher, go ahead.
Quick question on OpenShift. So this dawn line is like super easy, quickly done. If you want to host your own OpenShift, how complicated is that? Like on the
So all of Red Hat's technology has some upstream associated with it. So if you don't want to spend any money at all, there's OpenShift Origin. It is the completely open source version of OpenShift that has Ansible installers. So So if you have CentOS or RHEL running in your environment, you can install Virgin and not pay anybody anything and play with it and have fun. It takes about 30 minutes to an hour to install. It's actually all pretty automated.
How much, like a gigabyte and do you need typically for run a
The minimum, I think the minimum requirement is like 16 gigs.
Oh, okay,
memory per
16
node.
gig per node.
There's some overhead that runs. It's true of Kubernetes actually. There's some overhead that's running. There's different agents on the.
I mean, you need like a 32 gigabyte laptop for sure.
I didn't bring it with me actually. I think it's sitting at home, but I have a little Intel NUC that's got 32 gigs of RAM and like a 500 gig thing. I installed Openshift on that physically before it's on. And you can demo all one with that little box. Mini shift kind of strains on some of
Some of the
what you're trying to run.
Did you say you were technical or in sales?
I'm technical sales.
Okay.
So I go with the sales guys and answer all
I
the
was
questions.
I'm listening. I'm like, I'm trying to. All right, thank you.
But he's awesome. Rich, you're an awesome guy.
You know,
He's done more for
If you want
KeyLUG.
to have a different career of being a solution architect, being a technical sales guy, it's kind of a fun job.
Yeah. Oh no, I'm not
I
slighting
get-
you.
Yeah, I get like travel and all kinds of points. And
You've done more for
Free trips.
KeyLUG than I have. I know that much. Thank you for obviously your help on OpenShift there. Rancher, I put this in here. I don't know too much about Rancher. It's another container management platform. It does use a little bit of Kubernetes, but it has kind of shifted into its own little world now. I provided 2 different quick starts there. If you wanted to investigate Rancher, I'll be honest, I haven't heard great things about it, but it seems to.
I've started using Rancher. Rancher is used as the coordinator for Kubernetes worker nodes.
Okay.
And I'm using it as sort of the control node for, I'm actually running it on top of AWS, but it's in separate VMs. So I've got one EC2 instance in Amazon running Rancher, and then 2 big instances, EC2 instances running the Kubernetes worker node. So you've got to configure then NFS, network file system, among the 3 nodes where one of them, like the Rancher node, is the master NFS node, and then you're sharing data on the NFS platform between the worker nodes and the Rancher.
Yeah.
And then Rancher Rancher controls the pods.
Okay. Amazon. Now we're finally off of Kubernetes. We're on to some other things. Thank God. ECS is actually one of my favorite container management platforms. And like I said, I'll talk about the differences between the naming of things. But ECS just lets you stand up containers. They're called tasks inside of container engines or container instances, which are just instances. It's okay. It
But how
works.
do you choose between ECS and AKS?
So AKS is Kubernetes. This
Right.
is its own management platform that's not Kubernetes. It may be Kubernetes under the engine, but Amazon doesn't talk about it. It's its own thing that's not. It doesn't look like Kubernetes. It's something different. It allows you to stand up tasks, which could be groups of containers behind services, which are just make the task that's presented as a service persistent, and it's always like a service is kind of like a mixture between a replica set and allows for the service to be available and attached to maybe a load balancer, which we'll actually talk about here in a second. Azure Container Service, kind of like it's not Kubernetes. It's kind of like, I guess, AWS. I haven't used it, but it allows you. It's the same. Allows you to stand up containers inside of Azure. Kind of interesting.
I mean, just from a business standpoint, Microsoft is terrified of Amazon eating the world. But
Yeah.
It's really a threat to them, and they're investing $10 billion a year building out the Azure data centers all over the world. They have just buildings full of blinking lights that aren't being utilized that heavily right now, but they're laying down the infrastructure.
Which is why they're able to offer running Kubernetes
For
for
free.
you
Right.
for free compared to Amazon making you pay 20 cents. I think that extra 20 cents is because they actually want you to, they would prefer you use AWS Fargate, which I have a demo of. Fargate is really interesting. It's ECS, so it lets you stand up tasks and containers. Fargate takes it a step further and you don't actually run it on any of your own instances. Amazon will manage the actual instances for you. So let's go ahead.
On ACS, you need to have instances,
And ACS, yes.
the container service.
Yes.
Is this functions as a service? Is this like the serverless stuff?
No, it is containers,
Okay.
but the big difference is you don't run the instances.
They're managed.
For managed EC2s.
You don't even see the EC2 instances.
Right.
But
There's
it's-
EC2s
schedule
on
by
the back end.
container, period.
Yep. So when we look at this, it's pretty
It's
cool.
a managed service.
This is what blows me away. So let's see, can I say? Yeah. Okay. So we're gonna do the real quick getting started Amazon EC using Fargate.
What's the cost of it compared to other?
It depends on the size. Fargate, pricing. You pay by the service itself, and I think it's by the service and by the size of the memory attached and the CPU. So,
So it's
we
just
could
some of
do
those
some-
two then?
say again?
It's almost like
So if you have one virtual CPU and 1 gigabyte, you add both of those up.
I believe so.
It's kind of like paying for an ECS thing.
Here we go. So total, so example number 1, we want 5 ECS tasks running for 10 minutes, 600 seconds every day for 30 days. And each ECS task uses 1 vCPU and 2 gigs of memory. So you total the vCPU charges, the number of tasks times the vCPUs times the price per CPU second and CPU duration. So to run 5 tasks for 10 minutes every day for 30 days. So 300 minutes times 5, that's 1,500 minutes of processing on AWS costs $1.27.
Pretty good.
It's pretty interesting. It's kind of, it's different. It's pretty
No,
easy.
you can let your task drive the cost rather than just having an EC2
Yeah.
instance running.
That's immensely cheaper than running the instances. So we're just going to do an Nginx container, and I'll get into these. Like, so container definition defines the actual container or containers inside of a task. The task defines like how big a task is, how many containers are in that task, how the networking is configured. So we're going to spin up Nginx latest on a 0.5 gigabyte and 0.25 vCPUs.
So would you say this is like more fine grained than OpenShift Online? Like OpenShift Online is just a monthly cost.
That's what I was saying, was with OpenShift.
You can use up to a certain amount, but you're not really doing anything. OpenShift Online, you're creating projects and apps.
Yeah.
You're not really
Yeah.
dealing with
This is, we're back to managing, not so much managing the instances, but we are more fine-grained on how the task is actually going.
Can you manipulate the networking capabilities? Like
Yeah,
you can
so,
talk-
So this is where everybody now running apps? I mean, are you running websites on the container service now?
yes.
Sure.
Yep.
Okay. You don't, yeah, use this instead of instances then.
Oh, yeah. Well, I use ECS with instances. Fargate, like, it depends. I'm happy to go into it. So, like, the way I look at it now, if I have a persistent thing that's going to be available 24/7, I'll probably run it on ECS with managed EC2 instances that I control. If it's like a little one-off service that kicks off every day, I throw it in Fargate. Does that make sense?
Yeah, but I don't know why you do either one. Why would you do Fargate versus I don't know what you're saying.
So like the daily running, or the thing that's running all the time, it's going to be cheaper for me to manage those instances.
In Fargate.
No, it's going to be cheaper for me to manage the instances.
Manage the instances.
If it's running every day, all day. If it's
Okay.
one off, just something real quick
Right.
that needs to spin up, like maybe it's backing up some indexes in Elasticsearch
Okay.
or something like that, then I throw it into Fargate
Fargate.
because I don't need to worry about spinning up an instance for it. It
Oh.
just comes onto my network, does its work, and shuts itself
Is
off.
that like a Lambda task running?
So-
or something?
What I've heard, and AWS Columbia, I guess, coined this term, they look at Fargate as fat Lambda. And so
Okay.
Lambda has the largest size that it can get is 3 gigabytes, and it only has 500 megabytes of on container or on Lambda physical storage
Mhm.
or storage. So you can definitely, especially for like a backup job, run out of space. If you run it in Fargate, you've got a lot more space. You've got a lot more memory. And also with Lambda, you have a 5-minute window that Lambda's open.
Oh, yeah.
Fargate will run until it's done.
Oh.
So that's why you see a lot of people, I guess, looking at Fargate. So now we're gonna just specify a service. We're not gonna put a load balancer. So it's just gonna get exposed on a public IP of this Nginx service. And we're just gonna put it in the default cluster. And when I click next, what this is actually gonna do is it's going out to CloudFormation, and it's gonna stand up all the resources that we want automatically for us. So we can watch this event come online. Fargate is pretty interesting. I still really like OpenShift in the sense of you focus on the application and just let OpenShift run everything for you. With this, we're clicking some buttons. We're getting Amazon infrastructure stood up for us. It's trade-offs. It's whatever's easiest for you. That's, I think, the culmination of this talk is. There's a million ways to run containers now. It's however you want to do it. If you want to really do fine-grained control of how the infrastructure is set up, you could go towards a Fargate. You could go towards running Kubernetes yourself. You could do all those things that you really need to do if you really want that fine-grained control. Or you could just deploy the code with something like OpenShift, or maybe take a little bit of, go in the middle and go towards maybe a Fargate of you still are deploying the code yourself, but you're doing a little bit of work to actually get the infrastructure. There's a million different ways. It's crazy how many different ways there are to do this.
How bleeding edge you want to be also.
Yeah.
So OpenShift is all about enterprise stability and predictability. So Kubernetes does releases every 3 months or so. They're giving me a nice minor upgrade to the product, and they're only maintaining compatibility like 2 or 3 minor releases back. So there's some of these services, Azure's container or Kubernetes service, Amazon's Kubernetes service, they're advertising the latest Kubernetes. They're very current, but there's risk to that.
So this stood up our ECS task. It stood up its own VPC and virtual gateway and public subnets. Stood up all of our Amazon infrastructure for us, and we've now got a task that's available on a public IP, and it's got us an Nginx container. Took maybe 3 minutes or so. It's rarely available. We can even take a step further and look at the logs. We can see that we hit refresh on this.
And that was just a built-in Nginx, or where did you get it from?
It pulled it from Docker.
Oh yeah, okay.
Yeah, but you can point it at the Amazon Container Registry, the Elastic Container Registry ECR. So I just hit it a couple of times. You can see we pulled up that thing. So we've got logs available to us, and just like that, we can say, okay, leave the cluster.
But where did you get? Can you go back to like the screen where you got it from?
Yeah, sure. Let's let this finish delete, and I can go back to that getting started thing.
Yeah, I guess it's always on the getting started screen. Right?
Right, but since I have a cluster there, getting started is not there anymore.
Oh.
It's maybe I can do that. Getting started. 1 second. Oh yeah, hey look, get started. Perfect. Yeah. What were you saying?
Oh, okay.
So
it's
yeah, I'm
always here.
specifying
Okay.
this Nginx here. Nope. Hey, here we go. So yeah, it's just specifying the image of Nginx. And what it defaults, so the way that Docker kind of works, if you don't specify a repository, like remember maybe like 700 slides ago where I was specifying k8s.gcr.io. That was the Docker repository for Kubernetes and Google Container Repository. If you don't specify that, it goes to Docker Hub. So we're pulling Nginx latest from Docker Hub. So yeah, Fargate's kind of interesting to me. OpenShift Magnum. Anybody's ever done anything with OpenStack? OpenStack is like sets you up, allows you to set up your own like private cloud. So you get a lot of the same things that you would get with running on Google or Amazon, but you could run it internally in your own data center. and I realized that says OpenShift Magnum. I should say OpenStack Magnum. It's their container system. I haven't used it. I in fact try to stay away from OpenStack specifically because it's burned me like 600 times, and I shudder when I hear about it. But I had to put this in there because it's another container management platform that allows you to.
If you think of your container system as like managing containers, when it starts to get saturated, those heat templates can trigger OpenStack to add another virtual compute node, so you can scale out the infrastructure to handle more containers.
Yeah. Heat's sort of like OpenStack's version of CloudFormation or Google's resource standing up things.
But then, so OpenShift Magnum is running the heat service from OpenStack.
Correct.
Is that right?
I'll be truthful, I don't particularly
I just know
know.
there's a heat template. I don't know exactly how that works.
It's got to be running something.
Because all of
OpenStack.
OpenStack is a bunch of APIs
Yeah.
and different implementations.
That may or may not be
Well, but
working
there's separate
properly.
components for OpenStack, and there's an OpenStack heat service.
No, I get what you're saying.
OpenStack, I literally.
Because we're exploring how to use it in pieces.
Don't use it. That's how you should use it.
Yeah, well, we have to use it. I have to use it, unfortunately.
He's a telco, that's all.
Well, I used to work for AT&T Government Services, and we used
I don't know what it is about OpenStack and
C2S.
telcos,
So
but.
Apache Mesos is pretty
We're
interesting.
stuck with it.
Apache Mesos is not really particularly for like web server applications. It's more for like managing big data processing engines. So you can have, instead of like you see over there, you have your Apache Hadoop cluster, your Storm cluster, and a JBoss data grid cluster. You can actually put it all on its single massive Apache Mesos cluster, and it'll do the work to distribute that work for all three of those data processing clusters across just a larger cluster. I used Apache Mesos probably 5 years ago, and it was pretty interesting. I didn't get really deep into it. If you're doing any sort of like big data processing and you have multiple types of big data processing engines, you probably want to look at Mesos specifically because of it's really big in the Hadoop community and the various other communities out there that are doing those processing things.
And there's a company behind this, Mesosphere, that offers commercial support. And then they have their own platform as a service called Marathon. You can combine with this.
Cool. And then lastly, Docker Swarm. I think that's last. Oh, no, and then I talk about terms that I've been saying I was going to talk about for a while. Docker Swarm, Docker comes with Swarm capabilities. Docker Swarm just basically says, okay, you've got a Docker host that you're running here and a Docker host that's running here. It allows you to swarm them together into their own little cluster. So I don't know why you would necessarily do this. Maybe if you've got a couple of machines that you want to connect together in its own little swarm, you could do that. But it's kind of Docker's native supported version. But yeah, I agree with you. It's kind of a thumbs down.
Interesting that Docker is now supporting Kubernetes.
I know, so they're having like monetary issues with their venture capitalists and getting the money back, and then several key folks left Docker.
Yeah.
So it's not a good sign
Yeah.
as far as the viability of the technology.
Man, they were riding that wave for a couple of years, and then all of a sudden it's just kind of so last.
One other, you may not consider it, but AWS Batch would be.
Yeah, I didn't.
Would be an AWS, somewhat of a
Yeah.
lightweight container management.
I would say AWS Batch is on the level of maybe like a Mesos competitor. Kind of interesting. I haven't used it. I've heard of it. It's pretty interesting. It allows you to schedule large amounts of data processing via very simple to use API. There's the command line utilities with it. It's kind of interesting. I haven't used it, but it's definitely something that's out there that's pretty.
Yes, basically workflow. It dynamically allocates your containers on different EC2s based upon your specification about how much processing you need. So if you have, something that's really lightweight, a step that's really lightweight, you can run it on lightweight components and scale them independently for each step throughout the whole process.
To close it out, we'll talk about the different terms I was talking about before. Originally I had this as Google, AWS, and then others, but I realized it's really Kubernetes, and then I guess AWS likes to do their own thing. So like they all have the idea of a cluster, which is just a set of machines and nodes and tasks that are just processing things. Kubernetes calls the smallest, simplest things inside of Kubernetes a pod, which a pod could be a set of containers or a single container inside of a cluster. In AWS, that's a task. So that task is either a container or a set of containers. Then in Kubernetes, you have nodes, which are just the actual machines doing the work. Inside of AWS, those are called container instances. Those are just the instances that are running those containers. And then lastly, we have, everybody just calls a service as the thing that's basically presenting the pod or the task as a thing that you can interact with, a state, maybe not a stateful thing, but like a persistent thing that's available to interact with. And then lastly, I think the big one we haven't really talked about was just registries, all the different ways that images are presented. Yeah, that's it. I know I've been answering questions off and on. I know I've been cutting people off. I just wanted to kind of get through these things. So I'm happy to answer questions that folks have now, and let's discuss.
2 quick recommendations. So there's some good books available. Marco, I'm going to butcher his last name, it's L-U-K-S-A. He's a Red Hatter, but he wrote the book Kubernetes in Action. It's a mammoth book. You can read it in PDF. You can read it like, electronically. Forget the hard copy. I'm 13 chapters into it. It's actually really good. It gives you a lot of background on Kubernetes, how it's architected, how all the different concepts relate to each other. And then one of my colleagues, John Osborne, I asked him to come today. He lives in Northern Virginia. He's got 2 small children, and his wife recently started working, so he said if he takes a Saturday morning off, she'll kill him. But he wrote the book Openshift in Action with another Red Hatter, Jamie Duncan. So both books are available. They tried to work with Marco to make sure there wasn't huge amounts of overlap. So Kubernetes in Action really does focus on Kubernetes. From that book, you can use either Minikube or GKE, like he used, to do the examples. And then OpenShift in Action bases on Minishift as well as another OpenShift cluster. So both resources are really good. Cool. And chapter 11 of the Kube book actually goes into the architecture and how it works, which helps clarify some questions. Yeah.
Question. In terms of container format compatibility, what does that look like across those technologies? Obviously, with Kubernetes, you do Kubernetes here, there, and everywhere. As soon as it's compatible.
Kubernetes will let you use the different types of containers container systems that are out there, like CoreOS and Docker. I think Fargate and AWS environments will only let you use Docker. I'm not entirely sure. I don't know about like Azure Container Engine or anything. But yeah, I don't know if that answers your question.
So one of the things Red Hat did early on, this was like in 2013 or 14, was the Open Container Initiative, or OCI. So there is a desire to have standards around both the instances that are running as well as the images that are formatted. Docker complies with that, although they were pissed that we did that. And so does like Project Atomic, which is an upstream thing, that's issuing different commands that replace some of the Docker functionality. So Scopio is a command you can use to run containers rather than using Docker. Builda, because the guys from Boston, Build AH instead of Builder, is how you can assemble container images. So there's different replacements for some of the Docker commands, but the goal is that it's standard. And then like he was saying, Kubernetes has something called CRI-O, which is the Container Runtime Interface for Open Container Initiative containers, so you can plug in any engine you want. So Kubernetes will work with any container engine that meets the CRI-O interface and is an OCI compliant container engine.
Okay. And OpenShift?
OpenShift is based on Kubernetes, and we drove a lot of that stuff on. So currently we're using Docker under the hood, but we're moving to the Project Atomic stuff, just because the OCI formats are interchangeable. So once we have the Project Atomic fully, mature, we'll be replacing them.
So essentially, they're all just using the same underlying container technology. They just have a different server client. Is that what you're saying?
Yeah, I mean, Docker was pretty innovative. It's a shame they didn't monetize well because they really did change the space quite a bit.
Yeah.
But they came up with this idea of a layered file system where you could reuse layers. So, and then have those assembled, those various layers assembled as a full image. So OpenShift is, or not OpenShift, but Docker's like a layer cake. So you can have this layer that's fully hardened and you blessed it, and then you layer on something else on top of that. And then, so this could be like your OS runtime, your Nginx runtime, and your application. When you instantiate that, you get like a virtual, ephemeral, just copy on write, but it's gone when you shut the thing off. But those things, those other layers are immutable when they're in the registry, and then that totality is registered as a container. So the nice thing is if you're doing, say, security controls, all of those things inherit from each other. So each container, each layer can override what's below it, but you can have sort of a hardened Linux runtime, and then on that top of that, a hardened Nginx runtime, and then you have your app on top of that. You inherit all the controls beneath that, and then you just focus on securing your app. So it saves you a lot of time and money.
Is that part of the open?
That is the Open Container Initiative. It's like Open Container Initiative specifies how things are stored in the registry, what they're represented as, and you can extract these, you can export these things as like tar GZs and then import them into some other system. So you can even sneaker net them across if you do two container images. And then OCI also specifies the runtime interface and how that's supposed to work.
So I'm running the automation application that required Rancher and then Kubernetes worker nodes. Will can OpenShift replace the Rancher control node? Like if we just put it on an OpenShift platform, who's the control node? Or do I still need to load Rancher and Kubernetes
Sure,
worker
I
node?
mean, OpenShift has a control plane, that's all the masters. Same thing with Kubernetes, there's a control plane, and then the nodes in the cluster are where containers are hosted. So you have a control plane that's managing all of those things.
Right.
Some of those nodes have agents running on them.
Right.
Like he was saying cube control was the command line. There's actually a cube, I'm trying to think of what the name is, like the cube proxy or the cube something that runs on every node in the Kubernetes cluster. And it's responding to requests from the API and different controllers.
Right, but I'm running Rancher as the controller node for the cluster of worker nodes.
So that would be replaced by the Kubernetes stuff. You didn't need Rancher.
Okay.
OpenShift. But the architecture is interesting because there's an etcd database that stores all of the desired state. There's an API that sits in front of that. Everyone talks to the API. No one talks to the database except the API. So if I want to create a application and run it as a container, I will contact the API and say I want to create an application. The API just makes CD, so-and-so creating an application. There's a whole bunch of listeners attached to that API, and they say, anytime an application is created, let me know. So the scheduler is going to get a notification. Somebody created an application, but it's not assigned to a node. So he's going to use whatever schedule policy exists, and he's going to say, I'm going to schedule this on node 5. And he's going to tell the API, schedule this to node 5. But he actually doesn't make it run there. Another notification will go out. Somebody just specified where this thing should run. So another controller will get notified, and it'll actually make that thing run at that location. So the nice thing about that architecture is any of those pieces can be replaced. If you don't like the default scheduling capabilities in Kubernetes or OpenShift, roll your own. All you got to do is talk to the API, that's a RESTful API on the API system, and then listen for the right callbacks coming back. So it's totally this disconnected architecture.
I was gonna pull it up real quick. When I ran the kubectl cluster info, it came back with a bunch of URL endpoints. We should be able to at least curl one and it'll respond back with JSON. This is just a list of APIs, and like I was saying earlier, like on Minikube, you can run a Minikube dashboard to see the dashboard that presents all that stuff to you. That's just a containerized application that's presenting the API. By default, that's not turned on because they would prefer you use.
Just do a Minikube up.
Yeah.
If you did a kube control get all dash dash all namespaces, you would see all of the internal stuff that's running.
One more time. What was it?
Kube control get all dash dash all namespaces. Dash all namespaces.
Yeah.
So this is everything running, and you'll see there's these cube system things
So
running.
there's the Kubernetes dashboard service that's presenting the actual UI that we were looking at. It has its own built-in monitoring. It has InfluxDB for monitoring. When you run kubedns, that's actually getting replaced, I think, in 110 with something else. But that's doing like the actual service DNS. So if you're on one container, and you want to hit this hello minikube, you can do like a DNS call for hello minikube.local, and it'll respond with the internal IP address of that thing, and you're able to connect to it. There's a couple other things.
Look, that's only listing services. I think if you did like a cube control get
Well,
pod dash
no, the
dash-
rest of them are up here.
Oh, they're up there. Okay, that's what I was wondering about. There's some other things I was looking for.
With all the different pods and replica sets you were talking about.
Yeah.
Yeah, so there's hello minikube, but I didn't start kubedns or kube dashboard. That was all started by minikube itself.
Like if you scroll to the pods, I think there's some like controller manager things running, and that's where.
Yeah, so
yeah,
hold on.
we're good. Yeah, wait for.
You know, instead.
That's good. So you got your storage provisioner, the dashboard, the DNS, the add-on manager if you want to add anything. There's some stuff I was looking for that's not showing up. Maybe it's just rolled into some of these other things. But you know, on Openshift, you'll see like a controller manager. So a bunch of controllers are packaged together, but they're all just listening and responding to things. So,
We should be able to get that on the big. I just stood up a bigger Kubernetes cluster because I got the money for 30 cents. I got this. It's a learning experience.
but it's that whole architecture, and it's all written in Go language. Go does not have shared libraries. It's all statically linked. So they write everything as these little tiny processes that all just interact with each other via RESTful API calls. So
Should be, there we go. It's up.
it's yet another thing to learn, right? The new languages are Go. Cloud Forms maybe look at Ruby, and now it's all Go.
IronNet's all Go. It's pretty awesome. IronNet is Go and a little bit of Python.
I gotta talk to you about your company, because we're doing a lot with Army defensive cyber operations.
Let's chat. I know a guy that will happily talk to you. Cause like we're just the software guys. We have red teams that'll do some pretty crazy
Were you
stuff.
at the DCO conference like last May or something?
Negative. See, it's after the demo. Now everything's going to shit.
Well, that's what you wanted to, right?
Yeah.
The funny thing about that conference, Patrick, was one of these little like mom and pop shop companies stood up there and did this presentation on their Kubernetes-based defensive cyber operations solution.
Yeah.
But the guy who was the principal of the company, because the company had the same name as him, said he turned this over to his interns last year, and this is what they came up with. So I'm like, great, like a bunch of interns threw this thing together. And it was just like a mix of every open source project you could think of, you know, in a bowl and stir.
That's
But
where
it
the
was-
talent is.
But it was well attended because it had all the buzzwords, right? Containers, Kubernetes, defensive
Yeah,
cyber.
but that's where you'll find all the talent that's coming out of school these days. People that tinker, you know, they're the high value folk. You know, as we go on and continue in our careers, it gets harder to learn. So those people are the gold standard.
Somebody once told me like his memory was a tube with marbles, and the tube gets shorter every year. And as you add more marbles in, more things roll out the other end.
Especially if you have kids.
There we go. So this is, I just stood up the whole Kubernetes engine with like 3 nodes, and this is where you were talking about. There's some other stuff out there like
Yeah, you got the cube proxy running.
there's
And
DNS autoscaler and a GKE cluster proxy, and then it does have the Kubernetes dashboard running and metrics server, and And Greg's here. He can tell us about Mosaic Power better.
Well, somebody asked about the space and what you guys do.
I just had a conversation with them in the,
Oh, perfect. Okay, yeah.
I'll repeat for others as they're interested.
But yeah, it's pretty interesting. We ended the talk like 10 minutes ago. No, just
Well, I guess I'll stop streaming then, because the discussion was good.
yeah. No, it was fun.
It really is about what your requirements are and what you're
Yeah.
trying to do.